Alright, so we want to find all the solutions to, I'm gonna do number 1, and I guess we'll just do the odds. But it says we got to find, first we need to find a single solution. Okay, so with grouping, if we could do -10 times +3 and get -30, okay, if that last number was -30, we try grouping. But we can't do that. There's no common x that we could factor out. So we'll go to the calculator here, and we get x cubed minus 10x squared plus 3x plus 26. And we graph. Okay. There's another theorem that would allow us to find the solution to this, but what we're going to do is we look at this and we see, okay, it crosses through, there's 3 real zeros. It crosses through in 3 very real places, but this one, not on top of an exact grid point, neither is this one. We want this one right here. Okay, so the second trace, we want to find a 0. Looks like that's between 0 and 4. I hit enter 2 times, and it tells me when x equals 2, y is 0. Okay, so what is that telling me for this one? Okay, x equals 2 will make that whole thing go to 0. The way we would write that is as x minus 2. Okay, so x minus 2 times something is equal to x cubed minus 10x squared plus 3x plus 26. Okay, we want to know what that thing is. What do we need to multiply? Well, let's do a little algebra. For algebra, we would, divide by x minus 2 to get rid of that. So we need to divide this whole side by x minus 2. Okay, so let's do that with long division. Okay, so how many times will x go into x cubed? Well, that would be, we'd have to multiply x by x squared to get x cubed. So x squared times x is x cubed. But then we also have to do x squared times the -2. We get -2 x squared. Okay? And that whole thing, just like in regular long division, that whole thing needs to be subtracted. X cubed minus x cubed, no more x cubes. But -10x squared minus a -2x squared, okay, so that's just plus 2x squared, is -8x squared. Then we're going to bring down the rest of it. We only need the 3x right now. And we say, well, how many times does x go into -8x squared? Okay, think about the numbers and the variables separately. So 1 times what is -8? -8. And x times what is x squared? X times x. So -8x times x is -8x squared. Funny how that works out. -8x times -2 is a positive 16x. Okay, and that whole thing, again, we're subtracting. Okay, so -8x squared, take away -8x squared, you don't have any more x squared. 3x, take away 16x, and you get -13x. So now we bring down the 26. And how many times will x go into -13x? Minus 13 times -13x. And then -13 times -2 is 26. And when we subtract that whole thing, we get 0. Okay, so it divides evenly, and the number, or the polynomial that goes in here is x squared minus 8x minus 13. Okay, so these two things multiplied together equals the original polynomial. They're factors of it. Okay. All right, so we already know one of our solutions for x equals 2. We'll make the whole thing 0. Well, what else will make it 0? That would be, switch colors, when x squared minus 8x minus 13 equals 0. Okay. I sure do wish that would factor, but it won't. So there's a couple ways you can find it. Quadratic formula, completing the square, and graphically, but graphically is going to make you round. So what I'm going to do is completing the square. Okay, I move the constant over. Now I need two numbers. Remember, I need b over 2, and that's negative 8 over 2, which is negative 4. And I need b over 2 squared. So negative 4 squared is 16. The b over 2 squared is what I add to both sides. Remember, if you add it to one, you got to add it to the other. And I get x squared, minus 8x plus 16 equals 29. Now I'm ready to complete the square. Factors of 8 or 16 that add up to negative 8. Oh cool, it's negative 4. It's always just b divided by 2. And that's equal to 29. Take the square root of both sides. We get x minus 4 is equal to the positive or negative square root of 29. Okay? Well, I can't take the square root of 29, but I can move that 4 over to the other side. 4 plus or minus the square root of 29. Alright, and there's my other two solutions. Alright, let us quickly do synthetic division. Okay, I'm not doing this problem. I'm still doing number 1. We're going to do synthetic division, which is same idea as long division. You're dividing the x minus 2 out of the big x cubed minus 10x squared plus 3x plus 26. So to do that, we first write the 0. Okay, what was our 0? It was 2. And then we write the coefficients to our polynomial. Okay, so we have, and you write them in order. If you don't have a term, you have to still write a coefficient. You would put a 0 in. Okay, so our x cubed coefficient is 1, x squared is negative 10, 3x, and 26 is the constant. Okay. If you're freaking out, there's a how-to video on Google Classroom about synthetic division, so please watch that. Okay, first thing, you just bring the first coefficient down. Then you're going to go 2 times 1 and put it right here, 2. Now we're going to add this column. Negative 10 plus 2 is negative 8. Then we do 2 times negative 8 is negative 16. Now we're going to add that column, and we get negative 13. And we do 2 times negative 13, we get negative 26. We add that column, and that is our remainder. Okay, so going to the left, if 0 is our remainder, negative 13 is the constant term, negative 8 is the x term, and 1 is the x squared term. Okay? So if you divide out a linear term from a cubic function, you're going to end up with a quadratic function. And check this out. That's the quadratic function I ended up with. Well, look, it's the same quadratic function I got from long division. And you're thinking, why didn't you tell us this? Well, synthetic division is great when you have a whole number like a 2 as your factor. But if it was like 2x minus 3, things get a little bit messier. And so that's why we teach you both. All right, I really like long division. I feel like it's easier to see. This is just a bunch of numbers, but it is very handy and very quick. Pretty easy. So, yay, synthetic division. All right, I'm going to stop this video here, and then I'm going to pick it back up and do some more examples, hopefully much faster than this one.